Dear students, in the previous class we discussed about the structure of atom and electronic configuration, valency and formation of ionic bond. So today's class we shall discuss about the formation of covalent bond. So formation of covalent bond takes place by sharing of electrons. Taking an example of methane formed by CH4, the atomic number of carbon is 6. So its electronic configuration is 1s2, 2s2, 2p2, 2 plus 2 plus 2, 6. Atomic number of hydrogen is 1. Its electronic configuration is 1s1. So here P can occupy maximum 6. So it requires 4 electrons. Hydrogen S can occupy 2, so it requires 1 electron. This is done, the deficiency of electrons is done by sharing of electrons. Let us see how it shares. Now outermost orbit in carbon there are 4 electrons. So that can be represented as 1, 2, 3, 4. Now how many it requires? It requires 4 more electrons. So that it will be sharing. Hydrogen requires 1. So that it will be sharing with hydrogen, that is 1 hydrogen electron, 1 hydrogen electron, 1 hydrogen electron, 1 hydrogen electron. So by sharing electrons you can see here carbon has got 4 electrons which was deficient, and each hydrogen is getting 1 electron from the carbon. So this is how the methane compound is formed. So here the bond formation is by sharing of electrons, that we represent as, that is the structure of methane is CH4. So this is how the covalent bond is formed by sharing of electrons. Previous class we learned formation of ionic bond where complete transfer of electron takes place. So this is how 2 types of bonds are formed. So next let us go to the difference between a physical change and a chemical change. So physical change. So it is a temporary change. So it is temporary change. And secondly it is reversible. A chemical change. It is a permanent change. And it is not reversible. Taking an example of ice, suppose if you have an ice cube, when it is heated or due to temperature, it will change into water, and again it is possible to change this water into ice. So this is a temporary change and we call it as a physical change. So it is a temporary change and it can be reversed. And chemical change is a permanent change and cannot be reversible. So for example, if you take a firewood, if you burn a firewood, it becomes charcoal and it becomes ash. Can we get from the ash, can we get wood? No, it is not possible. So it is a permanent change and it is not reversible. So this is the difference between a physical change and a chemical change. Now how do you say that a chemical reaction has taken place? How do you say a chemical reaction has taken place? Based on the fact there should be a change of color, there should be a change of state, or there is an evolution of gas. So evolution of gas has taken place. So there may be a change of color, change of state, or evolution of gas and change in temperature. seeing these conditions, we can say that a chemical reaction has taken place. Now let's go. What is a chemical equation? It is a short scientific way of representing a chemical reaction. It is done by using symbols and signs. For example, let me take a magnesium ribbon. The formula of magnesium is Mg, and you heat it. That is, you burn the magnesium. That is nothing but atom of oxygen. It forms magnesium oxide. So this is a chemical reaction which is written in a short form. So it is a short scientific way of representing a chemical reaction. Now a chemical equation has to be balanced. What do you mean by balancing a chemical equation? So according to law of conservation of mass, matter can neither be created nor destroyed. So what matter is there in the reactant, what is written on the left hand side is called reactant, and what is written on the right side is called product. So what reactants are present here, it has to be there in the product. So it can be neither created nor destroyed. It has to be there. So the equation has to be balanced. Why should be a chemical equation balanced? So chemical equation has to be balanced because according to law of conservation of mass, matter can neither be created nor destroyed. So the amount of reactant present in the reactant has to be there in a product also. Now in a chemical equation, reactants are written on the left hand side, products are written on the right hand side. Reactants are separated by plus symbol. Similarly, products are also separated by plus symbol. Reactants and products are separated by arrow mark. If a reaction is reversible, then it has to be written as a double arrow mark, and the conditions applied, whether it is heat or cold or catalyst added, everything will be written above this arrow mark. So balancing chemical equation, how you have to balance a chemical equation? Let us take an example of sodium. When reacted with water, gives sodium hydroxide plus hydrogen gas is liberated. Now what you have to do is, you have to write the elements in one column, then left hand side, then right hand side. So now what are the elements present here? Sodium, hydrogen and oxygen. So these are the three things which are there. So on left hand side, what is the amount of sodium present? 1. Here also it is 1. What is the amount of hydrogen present here? It is 2. Here it is 2 plus 1, 3. Oxygen, how much it is present? 1 here and here 1. So you see here, hydrogen is not balanced. So you have to try to balance. It is a trial and error method. Always you can change the number in front of the compound. You cannot change these numbers which are below. Only you can change the numbers in front of a compound. So now let us see, hydrogen is not balanced. So and in balancing the equation also you have to see that hydrogen and oxygen are balanced at the end. Other element has to be balanced first. So but here other element is sodium, already it is balanced. So now I will go for hydrogen and oxygen. So let me try to balance this hydrogen. Let me put here 2. So what happens here? 2 ones are 2. Hydrogen 2 plus 2, it has become 4. So here it has become 4 right hand side. So in order to make this 4, I have to put here 2. So 2 2s are 4. So now hydrogen is balanced, and because I have put 2 here, oxygen has become 2 here. Here also 2 ones are 2. So oxygen has become 2 and 2. So now sodium has become 2 on the right hand side. So in order to balance this one, I have to put here 2. So now you see that all the elements in the reactant and products are balanced. So such equation is called balanced. So this equation is a balanced chemical equation. So this is what, how you have to balance a chemical equation. So next we will continue the class in the next